Continuing our review for tomorrow's test, we're looking at section 6.6. I can add, subtract, multiply, divide, and compose functions. So the first question is asking us to do a division problem. We are given function f is x squared minus 3 and function g is x plus 4. So if we set up our division, we have x squared minus 3 divided by x plus 4. Can either of those be factored more? Okay, we always look to see if we can factor it so that we can cancel out common factors. In this case, we can't do anything more than that. Okay, domain. We are worried about the denominator being what? 0. So if we say x plus 4 can't be 0, that means x cannot be negative 4. That would be my domain restriction. Okay, question 12. We are doing a subtraction. It says to take function f, which is x squared minus 3, and subtract, and make sure you put it in parentheses because you're subtracting all of function g. Distributing that, you should have x squared minus 3 minus x minus 4, and then combining like terms, we have x squared minus x minus 7. Any domain restrictions on that? Okay, so x equals all reals? Okay. Question 13 asks us to find a composite. Make sure you're watching the order because this is asking us to do g of f. Another way to write that would be like this. Okay, so we're going to start with function g, which was x squared minus 3, so something squared minus 3. And then what we're dumping into it is function f. So f was 2x minus 7. Then we have to square that. What do we get when we square 2x minus 7? 4x squared minus 28x plus 49. And then we're subtracting 3, so we end up with 4x squared minus 28x plus 46. Okay. If I asked for the domain on that one, when we do a composition, we worry about restrictions on the function we're dumping in, and we worry about any restrictions on our final answer. Okay? Are there any domain restrictions on the function I'm dumping in? No. There's no square roots, and there's no denominators. Looking at my final answer, any domain restrictions on that? Okay. So if you were asked for the domain, you'd say x can be all real numbers. Okay? All right. Question 14. Function f is negative 3x plus 2. Function g is x plus 1. This time they are asking us to do f of g. So we're going to start with function f, negative 3 times something plus 2. And inside we are going to dump function g, which is an x plus 1. Distributing, we have negative 3x minus 3 plus the 2. You should have negative 3x minus 1. Okay? Any domain restrictions on that one? No. All right. Question 15. It says f of x is 4x minus 1. G of x is x squared plus 3. We want to do a composition f of g of negative 1. Okay? Now, there's a couple different routes you can take to do this. You could dump negative 1 into function g and get that answer, and take that answer and dump it into function f. That's one option. The other option is to just do the composition, f of g of x, make it more generic, and then when we get it all simplified, then we can dump in the negative 1. Okay? So if we do the composition, we're starting with f, 4 times something minus 1. Inside we are dumping x squared plus 3. Distributing, we've got 4x squared plus 12 minus the 1 would be 4x squared plus 11. Any domain restrictions on the final answer? Any domain restrictions on the function I dumped in? Okay, so we can evaluate this for any x. There's no values that we have to worry about. They are asking us to find f of g of negative 1, which means we're going to put a negative 1 in here. Okay, So 4 times negative 1 squared plus 11. We end up with 4 plus 11. We should have 15 for our final answer. Okay with that? Okay. All right, looking at section 6.7, I can find the inverse of a function and determine if it is a function. So I'm going to start with a function, then I'm going to find the inverse and decide if that's a function. Okay? We've got y equals the square root of x minus 2. Just picturing that, you have a square root graph that's been shifted right too, correct? So that is a function. Yes? All right, to find the inverse, we switch x and y. To solve that for y, we're going to square both sides. And then we're going to add 2 over. So we have x squared plus 2 equals y. Is that a function? Yes? If it's a function, then instead of y, I would say f inverse of x. Okay? Go back to the original function, which was f of x. Now say I'm finding its inverse. So its inverse is x squared plus 2. You said it is a function. Now, the explanation has to be very clear. Are we running a test on f or on f inverse? Depends on which test you're running. I can look at this and say, based on f of the inverse of f being x squared plus 2, it's a parabola that's been shifted up, but it's just half of it, right? Because we only had 1/2 of the sideways parabola, we're only going to get 1/2 of the vertical one. So I have 2 answers. I can say, yes, it's a function because the inverse passes a vertical line test. I can do a vertical line test on the picture I just drew and say, yes, it's a function. Or I can say, yes, because f of x passes a horizontal line test. Either of those answers is acceptable. But you have to tell me which function or which graph you're doing the test on. Okay? All right, last one here. We have y equals x squared plus 4. We switch them. X equals y squared plus 4. Subtract the 4. Then what? Square root. And when I square root both sides, I have to do plus minus in front. Okay. Looking at the original picture, that is a parabola that's been moved up 4. Okay. Doing the inverse graph, it is a square root graph that's been shifted to the right 4, and it has both the positive and the reflected negative version. Yes? So, is the inverse a function? No. Since it's not a function, I'm not going to change that y and put f inverse because it's not a function. I don't want to put it in that function notation. Okay, I'm going to leave it as y equals plus minus the square root of x minus 4. What reason would I give? Say it again. Okay, so I can say no because f of x fails a horizontal line test, or I can say no because the inverse, and I shouldn't even put it that way, inverse fails vertical line test. Okay? Either of those would be full points. All right, so homework tonight. You are going to finish that yellow packet. Make sure you take some time and go back over the parts you did last night to review that before tomorrow's test.